Hello everybody. In this tutorial we are going to model a road embankment over a soft soil. This model right here. As a result of this undrained behavior for these soft soils, the effective stress remains low and the poor water pressure is excessed. After time, that excess poor water pressure dissipates, so the soil can obtain the necessary shear strength to continue the construction. In this tutorial our main purpose is to calculate the time for this soil to obtain the shear strength and dissipate the excess poor water pressure. So first things first, we have to open the software. Then let's describe our problem. The title I will write Embankment Tutorial. Then you can add your company logo. Then go to Model tab, Earth Gravity, Gamma Water, the X minimum and maximum. So let's demonstrate that. We have an symmetrical problem, so we can solve the half of this problem, and we have 8 meter here and then 12 meter. This gives us 20 meter. Let's say I would take another 40 meter, so we can get 60 meter in X direction, and for Y direction it's about these sand drains here. It's a square mesh of sand drains, 2 meters by 2 meters, so we can provide that we have just 2 meters in Y direction. So here we can input this for 60 meter, and for this is just 2 meter. Click OK. In the first step we have to define the material from here. Click Show Material. Then you can use this tutorial materials. I'm in tutorial 4 for clay, embankment, peat and sand. I will add them. You can edit it also. It's material model of soft soil. Most of people use more column. I don't know if there is or cam clay model. It's just undrained behavior to give us the consolidation settlement, and these parameters for C and phi and so on, you can modify it, the interfaces and so on. OK, hit OK. Then we have to add our borehole log at 0, 0, 0. Add this free material. Let's say that I have here the beat for 3 meter. Road embankment, I will add it in the structure tab, not the soil tab. So we have 3 meter of peat and 3 meter of clay, and I will take just about 6 meter for dense sand. So we will start by peat to -3, then the clay to -6, then the sand to -10. Let's say we have a head of water here for -1. You can add it here. See, this will change. That's the water level. Click OK. Then you can go for the structures tab. Here we will draw our embankment as a surface, then we are going to extrude it. So you can create surface. We have to write our points right here. So first point is just here for 0, 0, 0. Then we are going to 0, 0, 4. Then we are going to 0, 0, 0, 0, 0, 4. Then we will get 8 meter. So ouch, 0, 0, 0, 0, 0, 4, 8, 0, 4. Then shit, we have here 20, 0 and 0. So 0, 0, 0, 0, 0, 4, 8, 0, 4. This is the third point. The fourth point is 20, 0 and 0. That's our embankment here. Then we are going to make the construction stage for 2 stages. So we are going to divide this surface by a line from the half here to the half here. So we are going to the first for 0, 0 and 2 because it's 4 meter in height. Then we are going to 0, 0, ouch, 14 here, 0, 2. This is the line. Then we are going to extrude this for the 2 meter. This is the multiple selection tool. Then hit extrude object for 2 meter, hit apply. Then you have to delete the line, the points, and this line here, and this point and this point. There is no more points here, so we have to assign the material for the soil. You can assign the material for the soil in many ways. You can just choose from here or right click here, soil for set material for embankment. You can do whatever you want. Then we have to draw these sand drains for 2 meter by 2 meter mesh, and I'm going to study the half of the problem. So the first sand drain will be here over 1 meter, and for -6, 3 and 3 create hydraulic condition, keep pressing it, then release, choose the line sand drain 1, and I'm going to construct it here in the middle of the model of these 2 meters. So 1, 1 and 0 and 1, 1, -6. This is our sand drain. Then you can make copy of here. So I will use this array pattern in X direction for 9 columns. Distance between the columns is 2 meter. Here, okay. This is the sand drains. First I will make a run without these sand drains, then we will apply the sand drains to our model to verify or to validate its effect on the consolidation process. So we are going to mesh tab, then hit mesh. Oh, this is the refine mesh. I'm not going to refine it. I will choose coarse mesh. You can use medium or fine for more accuracy. You can view the meshes. This is our mesh. Hit close. Then you can select the point for curves. My first point will be here at the top of the embankment, and the second point will be here at the middle of the soft soil. This is the peat and this is the clay. Hit update, then go to water level. In this water level we are not going to add anything because we have added the water level in the soil tab in the borehole log. You can double click on it. We have added the head here to the -1 and it will read from it, so we won't add water level here. Go to stage construction, the initial stage. We have to make flow conditions. Water cannot flow from here. This is why, because we are solving asymmetric material, so we have the other part of the structure here, so the water won't flow from this, but it can flow from here, can flow also from here, and the top surface or the Z maximum of the soil is just a free surface, so it will be open. You can navigate in the groundwater flow. X minimum is closed, X maximum is open, and Y is closed, Z minimum is open. Okay. Then we can add the first phase and the second phase. Hit here. Then the initial phase is just the keynote procedure. Phase 1, we have to make it consolidation for just 2 days. Phase 2 is consolidation for 30 days. And this is why we will construct this part of our embankment and let it consolidate for 30 days. Okay, hit for the phase 1, then go to the soils, soil 4, activate here this part of the embankment, then you can go here to activate it. Okay, so we will construct it in just 2 days and let it consolidate for 30 days. You have to add another phase as a consolidation for this part of the embankment. Hit the time interval, we will construct it for 1 day, and then we let it to consolidate until the consolidation or until the soil obtain the necessary shear strength to continue the construction. This is our purpose. Choose consolidation, then the pore water calculation. Staged construction. Make it minimum excess pore water pressure, and P stop is 1. Okay. Press OK. Then here we will activate this. Okay. Now we are going to solve our problem and see in what time it will reach the consolidation. Hit calculate. I will pause the video until the calculation is done. So the calculation is done. We are going to show calculation. For the last phase, you can show the pour pressure P excess, or for phase 3, you can see it under the embankment or under the load. There is excess pour water pressure here. Now we are going to show our point which we have chosen here in the middle of the soft soil, the point P, to see the consolidation process within the construction stages. So click here for Curves Manager, New. For the x-axis I will add the time. For the y-axis I will choose the point P, stresses, pour pressure, PXS, I will invert the sign, hit OK. So from this curve we can validate what we are doing. For the first part of the embankment, this part, we construct it in just 2 days, so the excess pour water pressure has increased in the 2 days. Then we let it to consolidate for 30 days, so here it consolidated and the excess pour water pressure dissipated. Then we have constructed the other part of the embankment in just 1 day, so the excess pour water pressure has increased again. Then we let it to reach the P of 1, so here it has reached in 77.79 days. This action without applying our sand drains. So now we are going to apply our sand drain and compare with or without sand drain. Remember, it's about 78 days to consolidate. Yes, here these phases are construction stages, so I will start from the initial phase again to add another phase, but this time I will activate the line drain, the line sand drains here, and then I will apply the soil, but in just 1 day I will construct it. So for just 1 day here, and I will let it to consolidate in 1 day. Then I will construct the other one for 1 day again, and here I will let it to reach the fully consolidated. I will choose minimum excess pour water pressure, then I hit OK. From here, this is the construction stage, and here, oh, I'm sorry, I will just add the sand drain here, and then I will construct this. And here I will construct it. Okay, I think I'm ready for the second run with the sand drain. Hit calculate. I will pause the video again until calculation is done. So the calculation is done. We are going to view results, and now I'm going to compare the state without the sand drain and the state with the sand drain. So I will hit the Curves Manager, then I will get new time step from point P, PXS, I will invert the sign. It's something like that, but I won't show all the construction stage. I will compare it. So hit here for the setting, hit the phases. I don't need this. This is without the sand drains. Then I will add curve from the current point. We'll hit here with sand drains. Then I will choose the last phases. Hit OK, then OK. Now we are comparing with without sand drains and with sand drains. Without sand drains, it took around 78 days to reach the fully consolidated, and with the sand drain it took about 12 days. Then the construction process can continue. So if the time is very important, we are going to make these sand drains. Okay, in the design of the embankment, it's important to consider not only the final stability but also construction stage stability, and it's very interesting to evaluate the global safety factor about the slip circle of our embankment. So now we are going to make global stability factor for all of these phases. With sand drains or without sand drains, you can do it, but I will do for with the sand drains only. For phase 5, I haven't construct anything, but in phase 6 I need to make global stability, so I will add the construction stage with the phase 6. Then from the phases manager, I will get here for plastic, but not staged construct. Sorry, I will get it for the safety, and I will reset displacement to 0 because displacement in this stage can get excess stresses. Then here in the phase 7, I will add the construction stage for phase 7. It's safety, reset displacement to 0, and with phase 8 I will get it to safety and reset displacement to 0, and then I will calculate. Okay, our calculation is done. We are going to view the results. Okay, for phase number 9 we can view the slab circle shape from the incremental displacement. This is, and from here, and oh, I'm sorry, I meant it to be phase 9. Phase 9 is for the first construction, phase 10 for the second construction, phase 11 after fully consolidated phase is reached. We can also draw some curves, hit new, and from here we can for point A, deformation, total displacement, and here for multiplier, sigma m safety factor. Here OK, you can read it from here. Over the construction stages, you can also make some construction stages for it. Okay, deselect all, only phase 9. again this for stage 1. Then we can add curve from the same point here. Okay, can name it for stage 2. Deselect all for just phase. Here, okay. Stage 3, fully consolidated. Deselect all and choose the phase. Okay, hit OK. For this fully consolidated, it's around 1.45. Here is 1. You can read the accurate safety factor from here. Yes, edit phase. For phase 9, we're going here. So far, sigma m reached safety is 1.225. For here is 1, just 1. For here is 1.45. This is enough for this tutorial. Please leave your comments on this tutorial. Thank you very much. Bye.